Welcome to Young Timo Intellectual Educationalist channel. This video is a continuation of variation. In our two previous classes, we have discussed about introduction to variation, and we've also solved examples on direct and inverse variation. If you have not watched our two previous videos, please pause this video and watch the two videos before joining us in this class so that you'll be able to flow along with us. So today we are going to focus attention on examples on joint variation. From this example, we have P varies directly as Q and inversely as the square of R. If P equals to 1, when Q equals to 8 and R equals to 2, find the value of Q when P equals to 3 and R equals to 5. This is SSC June 2011 question. So let us start with the first part. It says P varies directly as Q. So remember in our first video we said if we have P varies directly as Q, it means P varies directly as Q. And inversely as the square of R. That means P varies inversely as the square of R. So P varies inversely as square of R. That is 1 over R squared. So we call it joint variation because we are going to join them together. So by combination, we have here P and P, we pick 1. Varies, we pick 1. Then we multiply this and this. That is Q times 1 over R squared. So this one will give us P proportional to Q times 1. That is Q over R squared. Remember we said we have to remove proportionality sign anytime we get here. So if we remove proportionality sign, we introduce equality sign and introduce a constant. So we now have P equals to, instead of proportionality sign, we have equals to KQ over R squared, where K is a constant. So now, let's go back to the question. They said, if P equals to 1, when Q equals to 8 and R equals to 2. So we need to look for P. So P equals to 1. Where K times, where we see Q, we put 8. And where we see R, we are going to put 2. We now have 2 squared. We now have 1 equals to K times 8. 8K over 2 squared is what? 4. So if you cross multiply, we have 8K equals to 1 times 4 gives us 4. So therefore, we now have 8K K equals to 4 divided by 8. So if you have to reduce it, 4 here 1, 4 here 2. So this one gives us K equals to 1 over 2. This is the constant. So to find the relationship between P, Q, and R, remember we are the one that introduced a constant. So we have to find that constant. After getting that constant, we substitute it back into this relationship. So if we put it back to this relationship, we are going to have P equals to, instead of K, we put the value of K we have gotten, 1 over 2 Q over R squared. When we get to this extent, anytime we have something like this, just push these two, push it down. This is how we can solve this thing quickly. So just push it down. And so we are now going to have Q over 2R squared. So why do we have to push it down? Let's quickly do something here. Remember that 1 over 2Q means Q divided by 2. So if you have Q divided by 2, then divided by R squared over 1. So we are going to change division sign. Anytime we see division between fractions, we change it to multiplication. So we are going to have Q divided by 2. Division will change to multiplication. Multiplied by, this will go up, this one will come down. Now be 1 over R squared. So Q times 1, Q. Multiply by 2 times R squared, 2R squared. That was how we were able to get this. But you don't need to go to this extent, it's a waste of time. So if you just know this method, it will be better. So this is now the relationship between P, Q, and R. Now, we move back to the question. Remember, we stopped here. So this question now says, find the value of Q when P equals to 3 and R equals to 5. After, anytime you are solving questions on variation, after finding relationship, any other question that is to be solved will be continuation from relationship. So from the relationship, we have P equals to Q divided by 2R squared. So here they say P equals to 3, R equals to 5. So we now have, where we see P, we put 3. Where we see R, we put 5. So we now have Q divided by 2 times R, which is 5 squared. So we now have 3 equals to Q over 2 times 5 squared means 5 times 5, which is 25. So we have 3 equals to Q over 2 times 25, give us 50. So we have this. So if we now cross multiply, we now have Q equals to 3 times 50. This gives us 150. Now, let's move to the second example. The second example we have, it takes 8 students 2/3 of an hour to fill 12 tanks with water. How many tanks of water will 4 students fill in 1/3 of an hour at the same rate? This is SSCE June 2017 question. Now, we observe that in this question, there is nothing like variation. But this is actually a question where that we can use variation to solve. So it might be difficult to solve this question without variation, but simply put, we can use variation to just quickly solve it, but it's a joint variation. How do we know it's variation question? Observe from here. They say it takes 8 students 2/3 of an hour to fill tank. We observe that if the number of students increases, the time will also increase. So, but if number of students increase, the number of tanks they will fill will also increase. So therefore, we will say that the number of students is inversely proportional to the time it will take them. But the number of students is directly proportional to the quantity of work they will do. That is the number of tanks they will fill. So if we are to represent, since we are talking about 3 quantities, if we are to represent the number of students by n, we represent the time taken as t. Then we represent the number of times they will fill as w. So we can now say the number of students is inversely proportional to time, because if number of students increase, the time will reduce. And the number of students is directly proportional to w, which means if number of students increase, the number of times they will fill will also increase. So we now combine them together. By combination, n and n will pick 1. Variation sign will pick 1. Then multiply this and this to give us w over t. In this time, we are going to remove proportionality sign and introduce a constant. So we now have n equals to kw over t. If we have it this way, we are now going to look for the constant. We are the one that introduced constant. We are going to find the value of the constant. So we'll go back to the question. Remember they said it takes 8 students. So the number of students now, n will be equal to 8. So here we have n, where n now give us 8. Then equals to k times, then the water that they will fill is 12 tanks. So multiply by 12. Divided by, what will be the time taken? They said 2/3 of an hour. 2/3 of an hour, to get 2/3 of an hour, remember that an hour is 60 minutes. So 2/3 means 2/3 of an hour. So this one gives us 2/3 of its multiplication. An hour is 60 minutes. So that is 60 minutes. So we now have 3 goes in 60, give us 20. So if you multiply 2 and 20, it gives us 40 minutes. So that was why instead of t, we substitute it with 40 minutes. So this is it. So here we have 8 equals to k times this, 12k over 40. So if you cross multiply, we have 12k equals to 8 times 40. So to find k, we have k equals to 8 times 40 divided by 12. So we are going to reduce it here. Remember, 4 here give us 2, 4 here give us 3. So 2 times 40 give us 80 divided by 3. So k equals to 80 over 3, which is a constant, proportionality constant. So we come back to that relationship. From here, n equals to kw over t. We have it here. Then we are going to substitute the value of k, which is that constant. So we now have 80 over 3w divided by t. Remember in our previous example, we said in this case, we can push this 3 down. And I've explained why it is that. So push it down, it will now have 80w over 3t. So this is now the relationship between number of students, the number of time they will fill, and the time it will take. This is the relationship between them. So now, the question now says, how many times, that is the number of times now, which we refer as W, is unknown. How many times of water will 4 students, the number of students is 4, fill in 1/3 of an hour? The time is 1/3 of an hour. So 1/3 of an hour, remember an hour is 60 minutes. Because we converted the first one to minutes, we have to convert this one to minutes. We now have 1 over 3 times 60 minutes. This one cancel this. This one give us 20. So 3 here 1, 3 here 20. So we have 20 minutes. So wherever we see t, we put 20 minutes. So from this relationship, any other thing we are looking for from relationship, we solve through that. N equals to 80w divided by 3t. So where we see n, we say it's 4, equals to 80w. Where is our w? Is unknown. Divided by 3 times t. Our t is 20. So we have 4 equals to 80w divided by 3 times 20 give us 60. If we cross multiply, we have 80w equals to 4 times 60. Then our w now is equals to 4 times 60 divided by 80. So here we have 0 cancel 0, 8 and 2, 4 here 1, 4 here 2. Then 2 here 1, 2 here 3. So we are going to have 3. That's 1 times 3, 3 divided by 1 is 3. So that means, therefore, 3 tanks of water will be filled by 4 students in 1/3 of an hour. So we are able to see 2 examples on the joint variation. It is now time to have exercise. So please, try to solve this exercise that will be given. This is the exercise. And if you are able to solve the exercise, these are the results that you are supposed to get. These are the answers. So if you find it difficult to get this answer, please go over the video again before coming back to the exercise to solve. Please don't forget to like, share and subscribe to this channel so that you can continue to get subsequent video. Our next example on our next video will be on partial examples of partial variation. Thanks.